Welcome to this episode of Mr. Layman's Knowledge Explosion. In Lesson 2, we're going to be talking about the converse of the Pythagorean theorem. Now, the Pythagorean theorem tells us if something is a right triangle or not. So what we're interested in is knowing if it's also an acute triangle or an obtuse triangle when it's not a right triangle. And a lot of these triangles will have square roots as their side lengths. So the first thing we're going to learn is, how do I approximate a square root? So in my mind, I'm not thinking square root of 5, I'm thinking approximately 3 or approximately 4, whatever that actually is. So we're going to practice that first. When we say approximate, we usually use this symbol, which means approximate value. So it's not exactly that. The exact value is root 5 or root 10 or 3 root 2 as I have them written. But we're going to approximate. Is root 5 about 2.3, 2.4? We're going to try and guess. And I'm going to show you how to do that. The best way to understand what the values of square roots are is to put them on a number line. For example, 1, 2, 3, 4, 5 could also be written in terms of square roots as the square root of 1, the square root of 2, the square root of 4, the square root of 9, the square root of 16, the square root of 25, the square root of 36, and so on and so on. So by using the equivalent values of the integers 1, 2, and 3, I can now see that square root of 5 would be in between square root of 4 and 9, or in other words, between 2 and 3. So since square root of 5 is bigger than 2, it's going to be 2 point something, but it's less than 3, so it can't be that. I want to try and guess where it is. Is it 2.9? Is it 2.1? So we look at the proximity of the numbers. 5 is a lot closer to 4 than it is to 9. For example, if I put the numbers in here, root 4, root 5, root 6, root 7, root 8, and then I hit root 9, which is equal to 3. Root 5 would be the very first number after the square root of 4. So I'm thinking this is only going to be about 2.1, 2.2, maybe 2.3 since there's not a lot of numbers in there. So I'm going to guess somewhere in the middle about 2.25. So when I see root 5, I'm thinking 2.25 or about 2 1/4 is the value of that. If I go to the calculator just to see if I'm actually close, because I want to do this without going to my calculator all the time. I actually was pretty close. The calculator value was 2.236. So for our purposes, getting close to 2.2 is good enough. And I can do that very quickly without a calculator if I understand my perfect squares like 1, 4, 9, 16, and 25. So let's do square root of 10. The square root of 10 would fall between the square root of 9 and the square root of 16. So again, I know it's going to be 3 point something very quickly. I just want to decide is it 3.1 or 3.9 because there's a difference there. Well, it's closer to the 9 side than it is to 16, so I'm going to guess it's like 3.1 or 3.2. I'm going to just split the difference and say about 3.15. Again, just so you know, my way of approximating these is accurate. I'm going to type it into my calculator and see how close I was. And the calculator says, I did pretty good on this one, the calculator says it's 3.16. So I was 1/100th off without a calculator in approximating what the square root of 10 was. And with a little bit of practice, you can get this quick and that close as well. And that's how you do it. You think, what are the two perfect squares on either side of the number so I can figure out what is between, and then what's closest. So now I'm going to get rid of the number line and just go back and look at the numbers. So we said that the square root of 5 was approximately 2.25. The square root of 10 we said was approximately 3.15. Now square root of 70. I'm not going to go back to the number line. I'm just going to list the two numbers. This would be between the square root of 64 and the square root of 81, which are the values 8 and 9. So root 70 is somewhere between 8 and 9, which makes it 8 point something. Well, 70 is kind of in the middle, but slightly closer to 64. I'm 6 away from 70 here, but I'm 11 away from 81 going the other way. So I'm slightly closer to the 8 side. So I'm going to guess somewhere close to the middle, like 8.4, 8.3. I'm going to say 8.35. And that's my approximate value for 70. Now again, I'm just going to punch it into the calculator. I don't want you to punch it into the calculator. I want you to estimate. Wow, I'm doing very good today. This one came out as 8.36. So the calculator told me that it was 8.36. Now the only reason I'm getting that close is because once I decide that it's 8.3 or 8.4, I just go right in the middle, 8.35, and that makes it look a lot closer than it is. That's just my little trick. Now the next one, you have to understand how square roots are set up. This is really saying 3 times the square root of 2. So what we're going to do is approximate the square root of 2 and then multiply that by 3. The square root of 2 would be between the numbers square root of 1 and square root of 4, which is 1 and 2. So this is going to be approximately 3 times 1 point something. Now there's not a lot of numbers between 1 and 4. There's root 2 and root 3, which means the gap are bigger. So it's not going to be, since it's only 1 away from 1, 1.1, it's actually probably going to be a lot closer to, say, 1.3 or 1.4. I'm going to say 1.4. Now I'm not going to 2 decimal places on purpose because I have to multiply it by 3. And I know that I think of this as 3 times 1 plus 0.4, it's a lot easier to multiply in my head. So 3 times 1 would be 3. 3 times 0.4 would be 1.2, or 12 with a decimal point. And then 3 plus 1.2 is 4.2. So 3 root 2 is approximately 4.2. And for our sake, that's good enough. Now I know that may have been a little bit crazy with the way I distributed that, but I do think that's the best way to think of these numbers when you have a number out front. So let's see one more. Let's see 2 root 10. Again, we're interested in the root 10 first. We actually already predicted what that one was. We said it was 3.15. So this is like 2 times 3.15. Again, I think of this as 2 times 3 plus the 0.15. Because then I can think of it as 2 times 3 is 6, and 2 times 0.15 is 0.30, because 2 times 15 is 30, with 2 decimal places is 0.30. So I'm taking 6 plus 0.30, which is 6.3. And that's how we're going to approximate these square roots. Do some as practice, and then look at the next video and how we use those to determine acute, right, and obtuse triangles.